Okay, so now we're going to talk about this concept of composition of functions. So here's the notation f round g of x. And what this reads in English is the function of f composed with the function of g. So f round g is also commonly and famously used as f of g of x. Alright, so this becomes that. So let's take a look at the idea first, and then you'll see how we're going to apply it in this class. So the idea is that we have a function f of x. And now let's suppose that we're just trying to evaluate it at some random value. So let's evaluate this function at x equals 1. So here we would say, okay, we would evaluate f of 1, and everywhere we see an x, we're going to replace it by a 1 now. So this becomes 2 times 1 plus 1. And then we could go ahead and solve for this, but I'm not interested in the solution right now. I'm just interested in the pattern. So the next thing we could do is, let's evaluate this at x equals 2. So this is at x equals 1. So now at x equals 2, we would say, okay, f of 2 would be the same thing as 2 times 2 plus 1. Alright, let's try at x equals 3. So at x equals 3, we can say, okay, f of 3 is going to be the same thing as 2 times 3 plus 1. And again, I'm not interested in the solution. I'm interested about discovering a pattern here. So let's say, okay, let's do it at x equals 100. So now we get f of 100 equals 2 times 100 plus 1. Now what we saw in the last couple of examples is that functions are not restricted just to numbers. We can actually input different variables here. So let's say we wanted to evaluate this function at x equals g. Then we will say f of g would be the same thing as 2g plus 1. And actually, let me write it right here so it's a little bit more clear on what I'm doing. So 2g plus 1. So again, I want you to notice this pattern. The only thing that changes is your input here. You see the 2 and the 1 stay the same. The only thing that changed was what I put inside these parentheses here. So it doesn't matter if it's 1, it doesn't matter if it's 2, it doesn't matter if it's g. The rule would be 2g plus 1. Okay, so now here's the punchline. So now we have f and we have g, and we want to compute f round g. So f round g of x. And here's how we do it. We're first going to evaluate the function at x equals g. So here, f of g, everywhere we see an x, we're going to replace it by a g now. So we have 2g plus 1. But now, we're going to apply our amazing substitution skills. Because in this scenario, g is actually equal to something. It's equal to 7x minus 1. So we're going to apply that substitution. So we're going to get 2 times 7x. Here, let me do it in yellow so you can see the substitution a little bit more clear. 7x minus 1 plus 1. Again, what I did here is I replaced g with that 7x minus 1. Because in this scenario, g is actually equal to this expression. So f of g is going to equal, now we got to simplify this right hand side. We can distribute this 2 here. 2 times 7x is 14x, and then 2 times negative 1 is negative 2, and we have that plus 1 at the end. We combine like terms by grouping these constants together to get a total of 14x minus 1. Negative 2 plus 1 is negative 1, and that would be f of g. So now here, this would suffice. F of g is 14x minus 1. If you want to be more technical, which, I mean, I don't think this is necessary, but f round g of x equals f of g of x, or f of g, which equals 14x minus. But again, this is just being a little bit extra. This is more than enough. So let's try some more examples. Let's try this one. So we gotta compute f round g, and again the strategy is to first evaluate f at g, so at x equals g. So here f of g is going to be the same thing as 6g minus 1, because again all that's happening here is the x's are getting replaced by a g. Now we can apply this substitution here because g is equal to x plus 2. So we can rewrite this as f of g is going to equal 6 times x plus 2 minus 1. And now we have to evaluate the right hand side. We can do that by distributing that 6. So 6 times x is 6x, 6 times 2 is positive 12, and then we have that negative 1 at the end. We can combine like terms. Here the constants are common terms, so we're going to get a total of 6x, and then 12 minus 1 is 11. So f of g is going to be 6x plus 11. Okay, so let's attempt this problem now. So we gotta compute f round g, which is basically telling us to do f of g. That's what this notation translates to. So we have to get f right here and evaluate it at x equals g. So everywhere we see an x, we're going to replace it by a g now. So we have negative 4g minus 2. And now we can apply that substitution. G is equal to 2x minus 1. So, and sorry, let me change this. This is supposed to be f of g. So f of g is going to equal negative 4. And then this g is going to become 2x minus 1. So I'm going to write 2x minus 1. And now we can simplify it by first distributing that negative 4. So negative 4 times 2x is negative 8x. Negative 4 times negative 1 is positive 4. And we have that negative 2 at the end. We combine like terms. So our like terms are going to be the constants. So positive 4 minus 2 gives us regular positive 2. So f of g is negative 8x plus 2. So let's do one last problem. So we got to compute f round g, which translates to doing f of g. So we got to look at the function f and evaluate it at the value of g. So everywhere we see an x, we now replace it by a g. And now we're in great shape to apply our substitution. G is going to become 7x. So we're going to write f of g equals negative 5 plus 3 times 7x. Simplifying this, we're going to get negative 5 plus 3 times 7 is 21x, and that's as far as we can go here, because negative 5 and 21x are not common terms. And that's it.